Okay, good day again, everyone. We're going to start today's webinar. Thank you all for joining wherever you are. Today's webinar is about vehicle to grid and the UAE. We'll cover the topic from different aspects, and we have excellent panel of speakers joining us today. My colleague Jason will introduce them in a minute. But just before we start, we'll give an introduction about the two organizers of this webinar today, the Clean Energy Business Council and the Emirates Green Building Council. I will do very quickly the introduction about CEBC, the Clean Energy Business Council. We are a not-for-profit membership organization based out of Dubai in the United Arab Emirates, and we cover Middle East and North Africa region. What we do as CBC, in a nutshell, our mission is really to accelerate the policy maturity across the MENA region for the clean energy sector. And we cover specific topics, which, as you can see at the bottom of the screen, future mobility is one of the most active sectors for us. And that specifically includes electric mobility, covering the infrastructure, the vehicle, how could we provide more incentives for the users, and the integration with the different renewable energy, with the different subsystems in the renewable energy system, including buildings, the grid, etc. We cover also energy efficiency, women in clean energy, low carbon hydrogen, and energy storage. And the last topic, which is also very important, is climate finance. We work to establish dialogues between the private and public sectors, and that's the key activity that we do, trying to accelerate policy throughout this active dialogues. And in parallel with that, we do a lot of research. We organize a lot of events. This one is one of them. And all of this research and events are publicly available for anyone to read and attend for free. So please, if this is your first time to attend one of our events, make sure that you subscribe to our newsletter, visit our website, and see our publications and the upcoming events. So now I'll hand it to Jason from Emirates Green Building Council to let us know just a quick overview about EGBC and what they do.
Thank you, Ahmed. It's a great pleasure to be here and facilitating this webinar with our partners, the Clean Energy Business Council. So my name is Jason John, and I'm the acting senior engineer for the Emirates Green Building Council. The Emirates Green Building Council is also a non-for-profit membership organization, and we were formed in 2006 with the goal of advancing green building principles for protecting the environment and ensuring sustainability in the UAE. Our vision is for the UAE to be a global leader for sustainability in the built environment, and we act as a catalyst for collaboration and a hub for excellence to promote sustainability. We do this through a number of our different programs. One such is our technical webinars that you are joining us today. These technical webinars are educational in their content and aim to promote or speak about and raise awareness on certain topics related to the built environment. And today we are happy to have such esteemed audience and speakers facilitating our webinar today on vehicle to grid in the UAE. So a bit of housekeeping notes, just to go ahead to the next slide. During the webinar, you'll see that everyone is muted and there will be no verbal questions during the webinar. But that does not mean you can't ask any questions. Feel free to ask any questions you might have during the webinar, during the presentations, and especially during the panel using the right-hand control panel you see on your right side. The team here will be monitoring the questions as they come in, and we'll try to answer them to the best of our capabilities. Or if not, we will address them to the panelists as and when required. So please submit your questions as we go along today's webinar. So that's it in terms of housekeeping. And let us start with our first speaker of the day. It is my pleasure to introduce our first speaker, Enrique Pastor, who is the Global Head of Sales for Electric Mobility Division at Schneider Electric. Enrique is the Global Head of Sales of the Electric Mobility Division at Schneider Electric. His mission is to expand the e-mobility business all over the world, contributing to creating net zero transportation through clean and efficient E2E electric vehicle charging infrastructure solutions. Enrique has been leading teams and businesses internationally for the last 20 years, working from France, Spain, and the UAE in the area of sales, marketing, business development, and general management. He is passionate about contributing to the digital transformation and the electrification of transport. Enrique, thank you so much for joining us. The floor is yours. Hi, Enrique. Sorry, you're muted.
Okay, I think now it's. Can you hear me now, Ahmed?
Yes,
yes,
perfect.
absolutely.
Oh, good. So let me show my screen, and then we go. I think. Can you see my screen now?
Yes, indeed.
Yes,
Okay,
if you can just put it in. Yeah, excellent.
Yes. So first of all, I would like to thank you and for the kind introduction and welcome everybody to this interesting call on very interesting subject about V2G and the journey to V2G. In fact, that's as we will see today. So yeah, it's again my pleasure to be here, and I really thank you for this invitation and for making me part of this informative session that I hope also from my side I will be able to provide some insights to the people. But as we discussed yesterday on the preparation, I'm also learning. We are learning here, everybody. So it's a new technology. It's a new trend, and it's very important that I mean the most important for me is really the Q&A session, where we will discuss about that. And I'm also looking forward to hear from the rest of the colleagues here from the other companies. So as it is a very brief introduction, I will not spend time explaining who we are, who Schneider Electric is. Just one statement, the mission of Schneider Electric is to be the digital partner for sustainability and efficiency for all the people around the world. So let's discuss about ECOS. I will do a very brief introduction, 15 minutes only. So we will see some data points to understand what is V2G and where are we going and where we stay today. So this is the vision of the e-mobility division of Schneider Electric. So we drive towards 100% electric mobility for a more efficient, resilient, and sustainable way to get to a net zero destination. So this is a common target for many of the companies in the world and for the humanity. So as I said, let's go directly to the point. So we are talking today about V2G and also how it affects the buildings, the needs of energy and electricity in the buildings. So we see more and more as electric vehicle is getting more and more adoption, even if still we are in the infancy of this market. We are seeing that the buildings are going to need more electricity and really energy management to be sustainable and to be able to cope with this increased need of energy for the electric vehicles. So one of the key shifts we are seeing when we are moving from a traditional ICE car to an EV car is that consumers will charge when they stop the car versus what is happening today, that we are stopping to refuel. We are stopping to recharge or to refuel today. Tomorrow, we are going to charge when we stop the car. So basically, 90 to 95% of the recharge of the electric vehicles are going to happen in buildings. So basically, at home, at work, and at destination. When we talk about at work, is more industrial, offices, buildings, when we go to work. And at destination is more about commercial buildings, shopping malls, this kind of places. And then 5 to 10% will be in transit. Of course, the recharge in transit is very important, is critical. So even if the amount of energy that is going to be supplied in transit is going to be small in comparison with the buildings, is very important because this will remove the range anxiety and this will increase the speed of adoption. So electric vehicles are going to account for a high percentage of buildings' electricity consumption. It's difficult to estimate. In the first estimation we have done internally, and now we are seeing in some reports, it can be up to between 25 to 40% when the mass adoption of electric vehicles will happen. The EV consumption might account up to 25 to 40% of the electricity consumption in a building. Of course, it will vary from type of building, from region to region. You know, in Dubai, typically, I've been living there, and in the Middle East region overall, it's very hot. So in summer, for sure, the HVAC is very important, the consumption. So this might decrease a bit the percentage of the electric vehicle. But anyway, it will be high. So I will come back a bit to the definition of the V2G and smart charging, but let's make some point here. Electric mobility means digital. Without digitization, we will not be able to manage the integration of the vehicles in the current electrical distribution networks. So starting by smart charging. So smart charging, when we do more than a simple plug, I plug my car and the car starts to charge. So if we put some intelligence in the system, this, first of all, this will provide flexibility to the network. This will provide much more flexibility to the network if we do something more smarter. Okay, we will see what does it mean. It will allow also intelligent consumption. It will allow to make the consumption of the car consumption more lean, more flat. Okay, avoiding peaks and also helping when the rest of the world is not consuming. The EVs can maybe take advantage of this low consumption to make sure that we consume maximum there. And for sure, in the evolution towards V2G, we have here a data point. We estimate in some of the reports or some of the analysis we have seen that moving forward to V2G, this will allow a 42% up to a 42% decrease on the cost of running the infrastructure and running the electric vehicle. Okay. Electric mobility means also green, so I will not spend much time here because this is not the subject of today. But basically, if the moment we are able to feed with renewable electricity all the electric vehicles, this will help a lot to reduce the CO2 emissions in the world. Okay. So let's go now to really the point of today of the vehicle to grid and the smart charging. So electric mobility means digital integration. So you can see here that there is a big need to integrate the electrical vehicle infrastructure basically in 4 ecosystems. We have the power distribution, the grid ecosystem. We have the buildings, the homes and the buildings with the energy and asset management that is needed. We have the distributed energy resources and microgrids, especially for the renewable and the microgrids. And of course, we can never forget that there is always a driver at the end. We should take care always in all our decisions, in all our technological, I would say, decisions, that there is always a driver at the end of the story. You know that and the user experience should be always good. So also very important before to go to the 2 last slides is that what is visible is the EV charger. So everybody is focusing on, everybody is talking about the EV charger itself. So this is the visible part. It's like kind of iceberg, no? So the tip of the iceberg is the EV charger. This is what everybody sees. But what is really needed to make sure that this charger has the right power, the right amount of energy at the right time coming from the right source is all what is not visible or is less visible, but is really needed. Of course, starting by the power infrastructure and the microgrid, the energy strategy and sourcing, as we discussed. If we really want to achieve the real CO2 emission reduction, we need to make sure that the energy is sourced from the right place. We need edge computing. We need to make the load management at the local level, but we need also operating software in the cloud. We need services, and in many times we need our customers need also financing, because sometimes the initial investment is a bit high. It's a bit it's remarkable, I would say, sometimes. And then the need of financing also should be put. We should put this need in the equation. Okay. So let's go now to the topic with this introduction that is a bit setting the parameters of why we need smart charging and why this will evolve towards V2G. So in Schneider Electric, we see the V2G or the smart charging towards V2G as a journey. So the step 1 is more or less where we are today. So it's a basic control with time of use, basic scheduling, and max power. So we define a maximum power that we have available, and then we can do a basic scheduling through the app of the car or through the app of the service provider. Okay. Step 2, and this is where we are really working now, is really to do the unidirectional charging control, so where the EV and the EV supply equipment can negotiate a charging profile depending on various constraints and data points. And this, we are still in the unidirectional charging. Today, most of the electric vehicles doesn't have the ability to discharge; they can only charge, and the same thing for the chargers. So here we have a lot to do already. I mean, before to go to V2G, that for sure is the future, and we need to go there. But it's very important we can increase a lot the efficiency and reduce the cost by doing a smart charging, and you will see in the last slide. Then the step 3 will be the bi-directional charging, but this vehicle to grid sometimes is a kind of concept. So people are talking about vehicle to grid, but we are talking about bi-directional charging, not specifically vehicle to the real grid connection. So once we start to see possibility to do bi-directional charging, it means charging and discharging the car. For us, the first step will be the integration with homes and buildings, so the V2H or the V2B somehow. This will be the business typically of the prosumer. So we are seeing this figure of prosumer really in US and in Europe really coming strong, where we as owners of the house can manage if our car is an additional source of power. And then the last step that for us, it will take still a bit of time. Today we are more in the pilot mode, will be really the bi-directional charging, the full integration of the vehicle with the grid. Okay. Again, I'm not the guru of that, but I just want to show how we see the journey. So we have done internally some I would say case study or initial just to compare the uncontrolled charging with a simple, I would say, or okay, with a load management system that can be very simple or can be more complex, and then what we call smart charging before to go to V2G. Okay, so in uncontrolled charging, clearly we see overloads. We see that we can really pass the power limit very easy when the cars are plugging. When we go for a load management system, here we have a lot of wins already. Okay, even if it is not very smart in the sense of is not incorporating a lot of I would say inputs from the EV owner. At least we will have a predefined power that can be fixed or variable. So the load management system can be I would say fixed or depending on the power available in the building. So we can measure what is the total power in the building, how much is being consumed, and then allocate the rest to the EVs. Okay. So in this case, the EVs are charged at predefined times to optimize off-peak tariffs, and we make sure we don't overload the installation or we don't cross the power limit. Still, some pain points are there because it's a reactive logic. The individual EV requirements are not taken into account, and then there is a limited management of electricity tariff and a low self-consumption ratio in case we have our own solar or our own power generation. When we go to smart charging, just taking into account the time of arrival, the time of departure, the amount of energy that the car needs in this time, just with that, and then the variable tariff, and if photovoltaic or solar is available or not available in the building, we can already make a lot of efficiency before to go to V2G. So in this case, the main highlights are the smart charging ensures optimal charging solution. There is a proactive logic with a schedule and forecasting. There is a management of the electricity tariff, and then we can increase a lot the self-consumption ratio in case we have solar panels in our roof, okay, or in our installation. So that's it from now for my introduction, and of course happy to take questions and looking forward to the discussion at the end. Thank you very much.
Fantastic. Thank you, Enrique, for the amazing presentation and summarizing up what V2G is and its various ways to get to that position. So right now, it's my pleasure to introduce you our next speaker for today's session. Is Tim Armitage, who is the Associate Director of Europe. Tim Armitage is an Associate Director with considerable experience of leading and contributing to multi-stakeholder projects within a range of mostly transport domains. Tim coordinates future mobility activity on behalf of Europe's advanced digital engineering practice. Tim has been involved in the delivery of projects related to e-mobility for over 10 years. He is recognized as a subject matter expert and presents internationally on the subject. He has worked for national and local governments, commercial organizations, and businesses, delivering strategic advice on the transition to zero-emission vehicles and the installation of all types of charging infrastructure. Tim has contributed to e-mobility projects in the UK, North America, Dubai, Vietnam, Hong Kong, and in China. So thank you for joining us today, Tim. The floor is all yours.
Hi, thanks for the invitation to talk to you today. Can you see my screen okay?
Absolutely.
Okay, perfect. What I'm going to talk about briefly for the next 15 minutes or so around the challenges of providing appropriate charging facilities in an evolving domain, and that will include a little bit about vehicle to grid and where I see that being. So I'm going to talk about the role of e-mobility in the intelligent mobility domain, which is the domain that I find myself working in more and more. Developments in technology, and then what this means for the built environment, particularly for integrating charging with buildings. The intelligent mobility ecosystem is really quite complicated. The system gets wider and wider all the time. And in a particular project that I'm involved in now, it also starts to involve at national level things like industrial strategy. So it's an ever evolving and complex domain. But in terms of mobility, there are a few trends around electrification, connected and autonomous vehicles, mobility as a service, infrastructure, data analytics, all sorts of different things which come together. But today, I'm really going to concentrate on this part of the intelligent mobility ecosystem that I've highlighted here, really around electromobility, property development, and just one or two of the core themes which I think are important to understand when considering this. And first of all, just the electric vehicle domain. You know, the first electric vehicles were around in the 1800s, and there it was basically, you know, the horse and cart, and inventors took away the horse and fitted some very early batteries and electric motors, really made possible by the invention of the lead acid battery. And those early vehicles were made obsolete pretty early on by the invention of the internal combustion engine, which really took over from the first electric vehicles. What I've called electric vehicle 2.0, though, was from the 1900s through to the early 2000s. There was still quite a number of battery electric vehicles going around in service in niche use cases, generally low mileage, low speed, often when noise was a requirement, or there was a requirement to work indoors. So lots of electric vehicles in warehousing and logistics. But then in the early 2000s, the current generation of electric vehicles began to appear from a mix of mainstream operators, mainstream OEMs, and particularly some specialist suppliers. And this third adoption, if you like, of electric vehicles, electric vehicle 3.0, was really driven by concerns around carbon emissions to start with, but later around health concerns related to poor air quality. So my point in this slide is really that modern battery electric vehicle technology is still quite new, and it's continuing to evolve. You know, it's been going for 20 years, so we're still quite early in the evolution of all these technologies. So why is this important? Well, battery electric vehicles provide one solution to the challenges that we're seeing around decarbonising road transport. Hydrogen fuel cell vehicles are another. They are electric vehicles, but they use a hydrogen fuel cell and hydrogen gas as their energy storage medium. You know, they're another possible solution. So it's not all going to be battery electric vehicles in the future. And there may well be others. There may well be other technologies that we haven't thought of yet, that haven't been developed. And future transportation is likely to rely on a mix of these powertrain vectors, you know, each one being suitable for a set of particular use cases. And for example, battery electric vehicles are probably going to be most suited to urban mobility, relatively short journeys at relatively low speeds, whereas hydrogen fuel cell vehicles might well be more appropriate for interurban mobility, vehicles that have really high duty cycles, and vehicles like heavy freight. So there's likely to be different solutions for different types of vehicle. And this evolution is continuing. I mean, Enrique had a slide which showed the evolution of the range of vehicles, and that's absolutely right. And here, what I'm showing is that since 2010, in the last 10 years, we've seen a huge increase in the average range of cars in particular. And there's a commensurate size in installed battery capacity in those vehicles that goes along with that, so a big increase. And that in part has been driven by the fact that lithium-ion battery costs are falling. There's been a colossal investment and continues to be a colossal investment in the production of lithium-ion batteries, which is not only freeing up some of the constraints in the supply chain, because there's been a shortage of electric vehicles, but it's also meaning that those electric vehicles are starting to become more affordable. And as vehicle ranges have gone up, vehicle batteries sizes have increased. There's also been quite an evolution of charger powers. In 2010, typically you would have 3 kilowatt and 7 kilowatt chargers. Maybe 2 or 3 years after that, we started to see at the time what we thought were rapid chargers, 22 kilowatts and 50 kilowatts. But right now, we live in a world where 120 and 150 kilowatt chargers are becoming quite commonplace for some applications, and even up to 350 kilowatts, which are, it kind of melts my brain when I think about this, that 10 years ago, I was installing 3 kilowatt chargers, and the most recent ones we've put in the ground were 350 kilowatts. And that's a real game changer in terms of the complexity of putting the chargers in, but also the cost of the hardware, both in terms of the physical hardware itself, but also its connection to the grid and where you can actually connect it to the grid. So some big changes there. And there's also been an evolution of charger power delivery. I mean, early in the 3 kilowatt, 7 kilowatt times, it was invariably a conductive cable that was used to connect the vehicle to the charge point. But other methods are now being demonstrated or developed and are still really at the point where the suppliers on the vehicle side and on the charger side are trying to resolve either some technical issues or some commercial challenges which go along with these new charging methods. But most of the things that I'm going to talk about here, all of the things that I'm going to talk about here briefly, have been demonstrated and do work. I mean, things like wireless inductive charging, which has been demonstrated both statically and dynamically, and that's particularly suitable for things like opportunity charging, where a vehicle needs to be charged partway through its duty cycle. Vehicle-to-grid systems that Enrique has already talked about that provide bi-directional charging and enable the vehicle to act as a distributed local energy source. That's a really interesting and exciting area, I think. We have pantograph charging. Static pantograph charging is used quite extensively for public transport vehicles, and there have been some trials of dynamic pantograph charging for heavy goods vehicles. And of course, battery swap is also the technology where the whole battery pack is removed from the vehicle and a new fully charged battery pack fitted instead of charging the battery on vehicle, the battery is charged outside of the vehicle. Now that's particularly prevalent for 2-wheel and 3-wheel vehicles in some geographies, but there's some developments with a few manufacturers, most notably in China, who are offering battery swap in passenger cars. So what does this mean for the built environment? That's the question I guess I've been coming to. The first thing that's important is to decide what type of vehicles are going to be charged at a particular building development. So that is the key question that enables all the other decisions to flow from that. The choice of charger and the choice of charging mechanism should be determined based on this review of the use cases of the vehicles that will be supported. There's no economic case for putting a rapid charger into a building where the vehicles are going to be parked there all day. Similarly, if vehicles are going in and out of the car park at a building, then there's no point in putting a 3 or a 7 kilowatt charger in there. So it's really important to match the charger to the use case. So I'm starting to run out of time here. In conclusion, to my points, the provision of charging infrastructure for zero emission vehicles does require careful consideration, particularly because of the speed of evolution and innovation and the early stage that we're at in this whole domain. So that there needs to be, it's very possible, it's very important that future proofing is built into any installation. Installations are quite expensive. They're quasi-permanent, if you like. So it's very important that the right technology is incorporated, and that the technology that is incorporated is appropriate, and that stems from this understanding of the vehicle use cases. It's not really something people have had to think about when providing a simple car park, but it becomes a really interesting and important consideration with electric vehicles and e-mobility. And I think that was my last slide. So thanks very much for listening. I'm looking forward to the discussion and to answering any questions that anybody might have.
Wonderful. Thank you so much, Tim, for the important and informative presentation.
Pleasure.
Next up, we have our last speaker in terms of presentations. We have Dr. Arnold Hoffman joining us. He's the Innovation Manager Group Strategy at Hager Group. Arnold Hoffman studied electrical engineering and holds a PhD from the, I'm going to try and pronounce this, Technische Universität Darmstadt from Germany. He's part of Hager's Group Innovation Department and responsible for energy management projects. Thank you, Dr. Arnold, for joining us, and the floor is yours.
Yeah, thank you for the brief introduction. Thank you a lot to the other speakers that kind of prepared the floor now for a case study I want to talk to you about. So I guess just help me. Am I sharing my screen? I hope so. At least I accepted it, and I hope that you can see it. Please
yes, we can
if
see
it's
it.
not
Yep.
the case.
No,
okay.
no, we can see it. Thank you.
Okay, what I will show to you is a slide deck that will start with a few, let's call them engineering slides that dig a little bit underneath the surface. I want to join you to have a look at what's underlying the shiny surface, and afterwards you will get the key messages or all the key results. Key topics that we analyzed in this case study in rather shiny marketing slides. So you have a bit of both worlds that I will present to you. I'd like to maybe just pick up a thought from Enrique, because he presented the charging of vehicles in 4 steps, and that's something I really like. Step 1 to 4, I guess in step 2 we were talking about kind of smart charging. Step 3 was vehicle to building, vehicle to home, and then we have the 4th step that is also called in step 3 bi-directional charging, and then we have the 4th step that is vehicle to grid. What I will show you now is, first of all, our first projects that we did that were part of step 2, which is smart charging. And then what we did is bi-directional charging project. And I will talk about this one as well as a case study. And of course, it's not yet doing vehicle to grid. That's absolutely true. What Enrique said, this is way more into the future. But from a technology point of view, it would be possible. The issue right here is more that that the regulations are not yet set up for that, and we will have rather quickly, we will mix energies from different sources. We will have grid energy in the battery, we'll have green energy in the battery. So when I sell it back to the grid or put it back into the grid, it's crucial right now that it's 100% clear what kind of energy this is in terms of payments. Yeah, so this is not done yet, but anyhow, we're rather close to this fourth step also to do it from a technology point of view, but those are issues that need to be solved. But now let me start with this vehicle to grid. What is it and why we need it? That was the title I was asked to talk about. First one, we call it intelligent charging, smart charging. It's the step 2 out of Enrique's slide. Sorry, Enrique, I will come back to your slide again and again. I really liked it. Okay, so what we did is something that we called at Hager, we called it the flow system. And we did a market launch now in 2020 in a cooperation with the Audi AG. A car manufacturer, you might know, they brought their first purely electric car to the market, which is not available with an internal combustion engine in this setup. It's the Audi e-tron. And the first project that we did with them together was about the cases that you see here in the lower right. It's intelligent charging. First one is local overload protection. Enrique, you discussed that as well, that a local overload might occur. The idea is really that here that the grid connection point of the house to the grid has, of course, a maximum power that it can deliver. And if you charge one car, maybe 2 cars, 3 cars, depending on how many cars you can fit into your garage at home, but also with one car, it can happen. If you have an aircon running or other appliances running, you might have to reduce the power in order to ensure that you don't, trigger your protection devices. So this was the first one, the first use case that was really highly required from the car manufacturer, because from the view of the car manufacturer, it's the worst case that the customer is very happy and proud of his new car. He plugs it in at home, and the car is responsible for a first power outage 3 hours after I plugged it in, for example. They absolutely want to avoid this, that the electric car is associated to, that's the type of car that leads to power outages in your home. That was the first idea, right? The second use case that we integrated in this project was the improvement of PV self-consumption. So if you have a photovoltaic system, it is able to schedule the charging according to the photovoltaic forecast, and therefore improve the amount of energy that you produce on your own. And this is a rather important use case, especially if you look into the electricity tariffs that we have in Germany, where we did this project. You have to see that you pay 30 euro cents per kilowatt hour if you buy it from the grid. Right now, if you build a new photovoltaic system on your roof, you produce at roughly 9 to 10 euro cents per kilowatt hour your own energy. So it's a third the price. It's a no-brainer. As soon as you have an electric car, it's a no-brainer to combine it with a photovoltaic system. The third one is charging based on dynamic tariffs. In this case, it's similar to the second one, I guess, and rather clear what is the idea. You have this EE bus logo. EE bus is kind of it's not really a communication bus, but it's a concept that defines use cases and also the type of communication in between the devices. And we heavily relied here on the use cases defined organization, and this is that was also done by Audi, and this was the foundation maybe for the communication between Hager and Audi. Well, this partnership was also visible in front of the customers. It was communicated by us. It was communicated by Audi that if you buy this car, you can get the charger from Audi and also integrate it with our energy management controller from Hager into your home. This is maybe, as I said, a little the engineering slide that shows you a little bit more the details. What you have the energy management controller, of course, here power supply, an additional meter. That's important because this additional meter will be the one that decides whether, or that measures the whole consumption of your building, including the EV charger that is required for the overload protection. You, in the energy management controller, you will set up what is the maximum, or the installer will set up the maximum power that is supported by your grid connection point, and this will be compared with the current value that can be measured. Here, what you see, this is the Audi charger, this is the Hager charger. Both are communicating with EE bus towards the energy management controller and ISO 15118 standard that is heavily pushed by the car manufacturers towards the car. This ISO 15118 communication standard can, for example, also well, deliver the charging profiles or set up departure times or the current state of charge and things like that. Valuable information in order to include it into the energy management algorithms. So that was Enrique's step 2. Now up to step 3, what we had a look here at the topic of bidirectional charging. Again, the slide gets a little bit filled up with other components right now. Maybe what is important, what remained is here our distribution board with an energy management controller inside that powers the regular AC loads. Now what we have here, and that is important to note, what we had to do is we create kind of something that we call the DC hub. And then this DC hub, it's basically an E3DC storage system that we used. E3DC is a 100% is a company 100% only belonging to the Hager Group, and they produce storage systems, battery storage systems for photovoltaic energy storage on site here in the building, and this system was used and added with a DC EVSE converter. So what was added? So it was modified. It was another DC-DC converter was added that is powering this DC charger. This is important. It's another requirement that for the discharging of the car, the preference here was to go on via DC bus. So we decided to integrate it here into our local storage system, where that will act as a DC hub in this case. This is the setup. Again, we're talking ISO 15118 towards the car. It's and the car here that is used is in this case a modified e-tron. It's not, it has slight modifications because right now it's not supporting the bidirectional charging. The scope of this project was, of course, to set up this prototype of a DC hub, a prototype of the DC charger and discharger of the EVSE, but on the other hand also to implement something that we called bidirectional charging IQ, so energy management algorithms that support this vehicle to act, so in this case not to grid but really more to home or building. I explained before, grid is currently still a regulation topic. down in the right corner, a more shiny picture of the team in front of the car in the lab where this bidirectional charging was set up. So here another insight, and where you can see the storage system from the inside that has different converters, depending on for photovoltaics, for the powering of AC loads in the direction of the building, and on the other hand, the batteries themselves and the DC-DC converter for the car. And the thing that is interesting here is if you look in this diagram, this picture shown on the right side, is that if you look at your household consumers or your regular loads, you now have 4 ways of powering them, and this is really, this shows you the high flexibility that you have in order to optimize your consumption or the provision of power towards your loads. You have, of course, the grid, you have the photovoltaics, you have the home storage, which is local from these batteries here, and you have the electric vehicle that comes in with not only the 12 kilowatt hours that we have in this battery system, but in the case of an Audi e-tron, easily 80-90 kilowatt hours, which is so really surpassing the local battery capacity by far. And this adds a high amount of flexibility to the home in terms of energy sources. So now let's get a little bit more glossy to an overview of the use cases that was done in the Hager and Audi vehicle to grid, let's call it a bidirectional charging project. Those are screenshots I took out of an animated film that I decided not to show to you here because, probably with a webinar streaming connection, it's usually not so much fun to see animations and or even videos. So if you are interested in seeing this animated, please feel free to jump over maybe after the seminar to YouTube on the Hager Group channel, and there you will find it in the videos. So what is done here is a couple of different use cases are shown and have proven to work. And let me go through them. The first one is charging with your own power. In this case, of course, the photovoltaic system that's installed on the roof will power not only your loads, but also charge your electric vehicle. As I told you, in Germany, this is almost a no-brainer because the energy is so much cheaper than buying it from the grid. And on the other hand, it's 100% green energy, and this is where we want to go, right? The next one is discharging power stored for short-term usage. In this case, it's when, for example, during nighttime, the PV system is not providing energy, and maybe the electricity tariff is rather high. It can make sense to boost the local energy storage system with energy already charged into your car. Cost optimized charging was another use case. So to charge the car if it's not yet fully charged with photovoltaics, to use off-peak times to charge the car to the required state of charge. The next is an emergency power supply. This is quite interesting. Maybe let me add 2 more sentences to that one. Emergency power supply in a country like Germany, where you have an average or power outage in the year that is less than 10 minutes per household, you could ask yourself the question if that's really worth to implement it. But if you look into our products where you can opt it in or opt it out, this function, it is one of the higher, we have extremely high requests for that by the customers. So it's really the peace of mind that they are willing, that drives them to invest into emergency power supply functions, knowing that they probably will never use it. So in countries where it's more more common that you have shorter or even longer outages of the power grid, it can be even more interesting. And of course, the electric car can then kick in and build up or support the local energy storage system again and boost up the capacity. So here you will get this animated in case that you go in have a look at our YouTube channel and look for this video. What is done here is different phases from charging with photovoltaics. Here's the dotted line. Here's the target state of charge that was identified that should be reached before the next departure in the morning. So here the charging is happening with photovoltaics. Here in this phase we are discharging. The sun has gone down and the loads are still running in the house. It's a high peak. It's peak tariff time, so we decided here to discharge the car in order to run the household. But at the end, we're still underneath the targeted state of charge. There's no sun expected until the departure. So when the tariff prices are lower, we start to charge from the grid. Then we have a waiting phase here. That was what was simulated here is kind of a grid outage at 6 o'clock in the morning, providing power and then charging up again when the grid comes back. So this is a little bit the idea how the different use cases go in hand during a day. That's it from my side. I thank you for your attention, and I'm very happy to join the panel session in an instant. Thank you.
Wonderful. Thank you, Arnold, for that wonderful presentation. So the next thing on our agenda, as Arnold mentioned as well, is we will be moving on to our panel discussion session of today's webinar. So may I ask all the speakers to just turn on their cameras and unmute themselves? Perfect. All right.
Hi. Hello again.
So it was a great couple of presentations that came, and we learned a lot in terms of what is the processes of getting to V2G, what is the expectations from the built environment, and of course case studies as well that we've seen as well. So we've received quite a few questions that came through, and actually my first question, which was going to be towards all of you as well, actually also came through as a question from one of the participants. So I'm just going to ask that to all of you, and let's have each one of you answer it from your perspective. So we seem to be in the very early stages of the evolution of V2G, looking at potential integration in the UAE or Middle East grid. How far would you estimate are we from a regulatory framework that supports V2G? So any one of you can just go ahead and answer that. If you have seen global best practices, maybe how would you overcome those? What would you suggest?
I think with all these new technologies, I'm probably not going to answer the question now, but I think with all these new technologies, there's two key things that are required in order that they can come into mainstream commercial use, if I can put it that way. The first is that there is a regulatory regime that is cooperative to their introduction. So there needs to be some regulatory basis to introduce them. And the second one is that there needs to be standards. There's when these technologies first come out, it's a bit like the Wild West until there can be some unifying standards, which then can allow the types of investments that are needed in order to bring the technologies into commercial use. So those are the two key things that are needed. I mean, I don't have any first-hand knowledge of what's happening in the UAE in terms of that regulatory basis, unfortunately.
Yeah, to add a bit on top of that, if I can also, I mean, again, I don't have this view on when it's gonna come, For me, what Arnaud presented, by the way, very good presentation also, Arnaud and team. So sorry, I was before of you. So good ones from your side, and I learned also a lot from both. So thank you for that. I think this standard, the 15118 that Arnaud mentioned, is the first step. You know, the adoption of this standard is the most important, and this standard is going in steps again. So it talks about the plug and charge. So first of all, today to recognize the car, we need to go with either with an app or with a token or something in front of the charger. So once the 15118 is implemented, normally you will plug the car and the charger will recognize the car and yourself. So you don't need to identify yourself every time. So this is one of the first things important in this standard. Second will be to somehow regulate the bi-directional charging. So this, of course, the standard is needed, but the technology has to be adopted by car manufacturers and also EVSE, I mean, the supply equipment, also manufacturers like Hager, like Schneider, like the others, you know. So this is a second step. And then this standard, once it is really going in this direction and it allows the bi-directional charging, then the regulatory compliance and the regulations might come. One of the key things is, of course, when you charge and discharge your car without knowing, because you might charge your car and the system might decide to discharge your car when it is vehicle to grid, this has to be under certain conditions, you know. So me as an EV owner, I will most probably, if it is not very clear what is the environment, how much of maximum power is going to take from me, at which cost, how much I'm going to get. Otherwise, if I don't get anything, why I'm going to somehow reduce the lifetime of my battery, because if you charge, discharge, somehow you are reducing the lifetime of your battery. So it makes a lot of sense when you are dealing with your own house and you decide what you use. But when it comes to vehicle to grid, of course, this regulation is very important. Otherwise, people, it's very simple. When the car is not charging, I will unplug the car. That's it, you know. So this is what needs to come in place to make sure that all the actors in the chain are really under the same frame. Okay? So this is what I can add, but I don't have a clear timeline. This is maybe more personal than Schneider view, is that it will take time. It will take time. It's not something for 2 years, you know. So it will take time. And the first step of this bi-directional charging will be more the V2H, the vehicle to home, or the vehicle to building when we talk about industrial facilities or fleets. You know, the fleets, it's a very important topic for e-mobility. Fleets is very important. Big fleets, and Schneider is one of the companies that have signed the EV100. We are going to move our 14,000 vehicles fleet to electric in 2030, you know. So then this topic about V2 building, when we are going to use it ourselves for our own facilities, will make sense. Okay.
Nano, do you have anything else to add to that?
Yeah, I guess it's yes and no. Maybe I totally agree, and maybe I just want to emphasize one point again. I think it has been said multiple times, but it's really going step by step, and and we have sometimes in some technologies you see, okay, the next step will be this or that, but you have almost no clue how you can get there because you don't see any intermediate steps, and it seems super far away and high investments and multiple things that are standing in between. This is, from my point of view, not the case here. This is why I don't doubt that it will happen. And those steps were really outlined before as saying vehicle to home or vehicle to building is already possible. We showcased it in a demo case, okay, but yeah, it was more in order to learn rather than to convince ourselves that it works. Yeah, that was clear from the beginning, but we showed that it's possible, and we also learned a little bit more about how car manufacturers think about it, because they have their restrictions as well. As you said, Enrique, you have maybe you say, oh, it's not charging, I unplug it, and they know that customers behave like this, yeah, and this is why they really push it even far and say, yeah, I have my restrictions as well with my car. I don't want the battery to work day and night, for example. You will, and this is those are the next steps, and those will be additional constraints. But again, a single electric vehicle has a battery that, I mean, right now, if you look at all the newer cars, they have 40, 50 kilowatt hours and more. And this is really incredible battery capacities that are being rolled out, that are on the streets. But as soon as they are parked, you said it before, people are charging them. They're charging them when they stop, not when the battery is empty. So though all those cars are connected to the grid, and usually they will not unplug it because it's not charging anymore, but because they want to leave. So so the cars are plugged for really a lot of time. And if you could maybe only if 1%, take 1% of the energy out, it can also already make a huge difference, simply because their capacities are very high, and they're gaining market shares. Yeah, and this is really an option. And as you said, first one, go to the home, and afterwards we can look what we can do for the grid. Totally agree to that. Yeah, and to the home, the regulations the barriers are way lower than for feeding into the grid.
I think, yeah, every one of you hit it right on the head as well. Is first we need to make sure the regulations and the strategies and the standards are set in place before we can start progressing. And I know I really liked your the point in saying we know what the end result we want to achieve, but the transition is what needs to happen before we can reach to that end result. So thank you for your wonderful comments. Arno, I'm gonna just follow that up with another question as well. So recently, last week or 2 weeks ago, I think it was, we had the sixth assessment report from the IPCC, and it's a very, very stark headlines that came through, where under all emission scenarios, the Earth's surface warming is projected to reach about 1.5 degrees, 1.6 degrees the next 2 decades. So electrification of transportation would draw energy essentially from the grid, and which is mostly fossil fuel based. So wouldn't it make much more sense, considering that we should focus on decarbonizing our grids before looking towards such capabilities such as V2B, V2H, V2 grid?
Yeah, it is in case indeed, if you decide to charge an electric car with electric energy that was produced using fossil fuels, the whole technology is getting, let's say, doubtful. Yeah? It's not so clear anymore. You can of course also go into the advantage, still go into search for advantages. Yeah, if you look for a fossil powered power plant that is running in its sweet spot of efficiency, it's still going to be more efficient than a decentralized internal combustion engine in your car that is always running depending on the power that you're requiring at very low load or high loads when you're accelerating, and almost never in the efficiency sweet spot. So this is of course a point where you can say, yeah, but I can run my power plants at least in a good efficiency, and also a large power plant can be built more efficient than a smaller combustion engine, but you have still the transmission losses. Okay, I get it, and it's really hard. It might be on par, yeah, but at least it's on par. It's not necessarily worse. And so from this point of view, I totally agree. But on the other hand, the decarbonization of our energy system is mostly decentralized. When we talk about solar, it's going to be solar everywhere, on every building, for example, on parking lots and things like that. And it makes sense to pair them with storage capacities. Those should be as close to the production sites as possible. That's always helpful, and it is makes sense. As I told you, in Germany, it's a no-brainer to have an electric car combined with a solar system. You have a solar system, get an electric car. It's the best way to make use of the energy that you produce. It's really boosting your personal business case for both, for the car and for the photovoltaic system. But this is something that you have to keep in mind, yeah. And so this technology is helping to integrate the renewables. But of course, you need to invest in renewables as well. And as soon as you invest in renewables, you will have the questions: how do I store the energy? And this is the moment where you will realize that an electric car is really a nice storage. Of course, it's not 100%. It's not available 100% of the time, because from time to time you decide to leave your house and go somewhere else. But it's maybe only a matter of time until all chargers are bi-directional, and no matter where you are, at work or whatever, you plug in and you're again connected to the grid, and your car is part of it. You get energy when there's too much, and you give back energy when there's a heavy lack of energy. Yeah, so this is maybe my answer.
That's
to
a
this,
wonderful,
unfortunately,
a wonderful
report.
answer. Yeah, it's a wonderful answer, because we have to realize as well, with anything that is nuanced, it would have a nuanced answer. So obviously, there are trade-offs in any sort of transition where we're trying to decarbonize our various aspects, and it's going to take time. But obviously, we need to make sure that we're combining the best and integrating the best of what is available in the market, and making sure that we're trying to get the best possible advantages, whether it be from renewables or from electric vehicles. Tim, I'm going to move on to you, and I have a question for you. So the infrastructure for electric vehicle charging continues to expand. In 2019, there were about 7.3 million chargers worldwide, of which 6.5 million were private, light-duty vehicle slow chargers in homes, multi-dwelling buildings, and workplaces. Only 12% accounted for publicly accessible chargers, most of which were slow chargers. So do you think there should be more concerted efforts to increase number of publicly accessible charging points? What do you see as like a ratio between privatized and public charging?
That's a really good question, and I think that will vary country to country, predominantly based around the type of housing stock in a particular country, in a particular area in a country. There's no doubt in my mind that for private dwellings with dedicated off-street parking, or eventually all of those will be equipped with electric vehicle charge points. It's a no-brainer. The difficulty arises when people don't have their own dedicated parking places, and that will undoubtedly be public charging. And I see, certainly in the UK, I see a huge number of public chargers now being installed, both by local authorities who want to help people who live in their areas to be able to adopt electric vehicles, but also now increasingly by commercial organisations who want to make a business out of EV charging. So I think we will see more public chargers, and there's still a perception, which I think is probably incorrect, that one of the reasons that we don't have so much uptake of electric vehicles is that there isn't the amount of charging posts that are required. And it's one of these classic market failures, and it's a chicken and egg situation where people who have electric vehicles, well, people who would like to have an electric vehicle say that they haven't bought one because they can't find places to charge it. But the operators of the charging scheme say, well, we've got all this infrastructure out there and it's heavily underutilized. So how we break into that, I'm not sure. I suspect that ultimately we'll end up with more public charging than we actually need, but just because that public charging is going to be needed to give people the confidence. It's a confidence thing, but it will become it'll become a distressed purchase to charge in public, because there's no doubt it will always be cheaper and more convenient to charge at home.
Great answer. Fantastically great answer. Enrique, the next question is for you. So we know that the market uptake for electric vehicles was increasing year on year, which was pre-COVID. Have there been any significant changes in a post-COVID economy, given that car markets globally seem to be contracting now?
Yeah, so very good question. It's something that me myself, I've come in this business in the middle of the pandemic. So I took this position. I've been 22 years in my company, and I took this position for the last almost 1 year. So I've been working in e-mobility, very happy and very committed to that. I'm really passionate about that. If I say a sentence, is we have seen an acceleration of electric mobility adoption. So this is the COVID has made everybody to understand that the sustainability of the planet, when we were all at home, lockdown and all that, we realized that the emissions can be reduced drastically, and this is good for the planet. So this gave an additional boost, and also, this is one of the pillars, one additional boost, that everybody is now very conscious about the impact of our actions of the economy in the sustainability of the planet. This is one thing. Second thing, for me, very important also, is about digitization, about people being more at home, about people being connected now. So this topic of electrification is fully, is going hand in hand with digitization. So when people are thinking digitization, this comes also as part of the story. It's much easier to digitize, and it's much more techy an electric vehicle than an internal combustion engine, where we can see, even if all the manufacturers are bringing more and more technology in the current vehicles. So as a conclusion from my side, what we have seen is the tipping point. The EV adoption was running maybe like this, and now we were expecting that the tipping point of the S-curve to become really exponential growth will be more on the 2022, 2023, but it's happening already in 2021. So countries like Germany, like Italy, especially in Europe, we see countries where the EV adoption is growing by 350%, 400%. That this was not happening pre-COVID. So of course, countries like Norway and the Netherlands that are more advanced. In Norway, for instance, this year, 85% of the ICE vehicles are dead in Norway. They will not exist anymore next year. So this is a reality. So in Norway, next year, the sales of ICE cars will be zero or close to zero, will be residual. So yeah, as a conclusion, we have seen an acceleration despite the conditions of the market, despite the overall the market of EVs. The market of vehicles has been is decreasing. The EV is really booming. So, and of course, the infrastructure should go hand in hand. One of the key things for me that also is helping to this point is that for the fleet, I was talking about fleets. For the fleets, especially the light commercial vehicle fleets, the total cost of ownership now is getting favorable already in 2021. So some fleets are shifting to EV, not because of sustainability, not because of green, it's just because of economics are working. It's because if I buy EVs, light commercial vans, is cheaper than owning ICE commercial vans. So this is one point. And we expect the price parity between an ICE vehicle and an EV vehicle to happen between 2023 and 2026. So a lot of people, Tim was mentioning some of the reasons why people are not moving to electric. One of the reasons, let's be clear, it's economics. So it's more expensive today to buy an EV than an ICE vehicle. But very soon you will go to a showroom and they will show you two cars that the external shape is more or less the same, range is more or less the same, and then the cost is more or less the same. So then, of course, in the running cost is much cheaper because electric vehicles have virtually zero maintenance. The cost of recharge is 10 times less than fuel. Okay, in some countries like UAE or some countries it's not the case. So I know it because I lived 4 years there. But anyway, it's cheaper to recharge at home if the price of the electricity makes sense, of course, than refuel. So there are many factors that are accelerating the adoption of EVs everywhere. Of course, the focus is now Europe and NAM, and North America, but the rest of the countries are also going in the same direction. Maybe 2-3 years, or maybe 2 years late, I would say, but they are all going in the same direction.
Wonderful. And yeah, I think it's really surprising to hear the fact that post COVID, or like after, like, once COVID and pandemic happened, it's really surprising to hear that the EV market is actually starting to increase, and because of that, the economies of scale are kicking into place and sort of bringing down that price barrier. So it's absolutely fantastic to hear of that. We've got quite a lot of questions that have come in through. So before I continue on with the questions that I have, I'm going to just take on a few questions from that we've had during the webinar. So I'll start with one of the first questions we got is, given the large quantities of lithium-ion batteries in cars being charged and discharged in underground car parks and the like, is there any fire risk, or do you need to have a fire risk management policy or regulation in place related to this?
I mean, from my side, what we have seen, I mean, electricity overall has a fire risk. So electricity is something that we need to control. So and especially, I mean, I talk here also for Hagen will be the same thing. We are specialists in making electricity safer, greener, and really under control. And the electric vehicle is an additional charge. Of course, the vehicle itself is more on the car OEM side. But from the electrical equipment manufacturers, for sure, we are putting all our efforts and all our experience and technology to make sure that charging a vehicle is not more unsafe than plugging a fridge, you know. So this is the purpose. Of course, we have seen and we will see some fires, but I mean, to have a internal combustion engine here in Spain this year, we have had a lot of fires that has been caused by cars that got burned in the middle of the highway. So then you park the car because you see the smoke, and then the fire is getting in the mountain. You know, so I mean, fires are a risk, of course, but in principle, it's not. There should be no more risk if everything is under control and you put the right devices and you do the right things. And this is why it's very important to rely on, you know, on experienced companies, and maybe we are a bit slower than others. But when we launch a product in the market, the product is fully certified, fully, okay. So this is for me the answer to this question. Yeah, there can be some additional fire risks, but not more than the rest of any other electrical equipment that is coming in place.
May I add maybe one thought?
Yeah, go ahead.
First of all, Enrique, totally agree. Our companies are both experts in making sure that electrical equipment does not catch fire. That's absolutely true. And the risk maybe that we can see, I mean, you remember not this manufacturer, but the South Korean one that had issues some 3 years ago, I guess, yeah. With a device that had a faulty battery design that had the risk to catch fire. Exactly that could happen in a battery electric car. But on the other hand, please remember that in traditional cars with combustion engine, you have also some liters of fuel that is highly explosive, even that you store everything that is stored in the basement of a building. Yeah, and we learned to handle this, and we will learn to handle that. And there's a lot of one of the reasons that battery got cheap is because the whole research was extended thanks to devices like those, and not because of battery electric vehicles. Yeah, if you look at the first Teslas that was built, I guess it was cell phone batteries. They just took batteries for several thousand phone and built them in that car, and that's it. And so don't forget about this. It's a risk that will come down due to industrialization and increasing knowledge within the car manufacturers. But battery packing itself is already quite known, except of some
very valid
issues.
point. Very valid point, Dr. Arno. One of the other questions we got, this is a very interesting question and close to our realm of the built environment. So from this question we received is from what the person understands. New buildings are accommodating or can accommodate charging stations, but how will the existing buildings accommodate this change? That's a very, very interesting question.
You mean, I believe this question is supposed to say, how can I connect the charger to a building that was built, let's say, 40 years ago, that has the electric equipment built in 40 years ago? Of course, it's something that needs to be checked, and that has to be set up by the installer. And I mean, it's a matter of seeing if how much power the equipment can provide that is installed, and whether it needs to be upgraded or not, or if you need to reduce your charging power in order to comply with the installation that is available on site. I guess that's more or less what I would like to answer to that. But
yeah, I mean, there's no technical reason why it can't be done. It might be cost prohibitive in some buildings, depending where the electricity comes into the building, and the location of that in comparison to where the chargers will be placed. But other than that, it's a relatively straightforward electrical installation, like any other electrical installation.
Yep.
And it's happening all the time. Right? And actually, what we are finding is there's a lot of interest from property owners, from real estate owners, from property owners who want to equip their existing buildings with appropriate charging facilities, because they want to make sure that they've got a property portfolio which is going to be attractive to companies to come and lease in the long term.
If I can complement a bit, for me, the key here, Jason, is first of all to listen to the customer and to analyze the use case and the business case in every building. And for sure, we need to make sure our partners are equipped with the right tools and technology to understand and to analyze what is the business case. Today, any building that is doing a pilot, putting 2 or 3 chargers, there is no problem basically, because the power is enough to feed 2-3 cars during the day. The problem becomes when it's mass adoption, when the building needs to come. Let's imagine a building that has to equip 50 places with, let's imagine, 22 kilowatt, not very high power, but okay, medium power. We are talking about 1 megawatt, okay? This is 1 megawatt of installed power. This does not mean, if you do, we come back to the beginning, and this is where we are a specialist in energy management. If we talk about smart charging, understanding the use case of the customer, listening to the customer, we can maybe increase only 200 kilowatt power in a building that needs 22 kilowatt charger, complying 100% to the use case of the customer, because not every car will need to charge full every day. Not every car will be plugged at the same time, and not every car. And then we can, of course, we will need some, in many cases, we will need to increase the power, but this increase of the power might come from the utility, or might come from solar panels, or might come from a mix between both and energy storage. And, so this is where digital integration and understanding the use case of the customer becomes fundamental. And we don't expect the amount of energy needed, the amount of power needed will not be at the same level in percentage of the amount of energy. So we will be able to provide, let's imagine, 50% more energy by increasing only 30% or 20% or 30, the power in the building, So and this is where really the smart charging and the digitization becomes super relevant. Not in the first pilot, but the people that are doing pilots, they need to understand that in 2 years they might need to electrify the full parking. So they start with a pilot that makes sense than just putting some silly chargers, not doing any load management or any digitization, to prepare for the future that will be closer than they expect. This is my message.
Absolutely, and I agree with your points, everyone, as well. Like, when it comes to retrofitting or refurbishment, you have to be very careful in establishing what is your end goal and what are you planning to achieve with the retrofit. And obviously, this is where energy management has to be integrated into it. So without sensible energy management, without sensibly taking the understanding of what the usage of that building is, it's not going to end well, basically.
Yeah, exactly.
A question for the panelists. This is another question we received from one of the participants. What amount of energy are we talking about that is becoming flexible through V2G? So the person references Arnold's chart where it looks like a plus or minus 2 kilowatt hour. So how much is realistically possible?
I didn't get the point actually. It was can you simply repeat? I
yeah. So what amount of energy are we talking about that is becoming flexible through V2G? So in terms of having a V2G sort of interaction, what sort of energy scales are we looking at?
Well, that really depends on the application, right? If you, there was one point that I did not mention that was tried as well, that is going with your car to a remote off-grid location where there is a house ready to plug in the car. As soon as you plug it in, you provide the electricity to this whole off-grid location. In this case, you might really need more or less all the battery, right? But okay, I hope not all, because then you're stuck there forever. You will not be able to get your car away. But yes, what I mean is, the less, the better in terms of the battery of your car, to not use it in heavy cycles all the time. But on the other hand, it depends on what we heard before. What is the compensation? I guess, Tim, you were the one putting that on the table, this topic. What is the compensation you get for that? Yeah. And this is really important to see it and to compare it. Is the customer willing to participate for this price and for this compensation he gets or not? And yeah, then it can be from several watt hours to, of course, several tens of kilowatt hours. And another point is, if I say I only need it for power outages, okay, when they happen once a week or once a month or twice a year, this is the moment I want to get as much energy as I need, because as soon as there's energy again, power comes back, I will be able to charge it. And I was able to power my home in this time. Then you don't care so much about that. So it heavily depends on the application, I guess.
Yeah, and the compensation piece is key, I think, because it's very difficult. It's very, very difficult to understand, because as an electric vehicle owner, you know, I know how many cents per kilowatt hour or how many cents per mile it costs me in electricity. So I've kind of got a handle on the value of the fuel, if you like. But what I have no idea about is the value of that battery cycle. I know I've only got a finite number of cycles in the battery in my car, but I really have no clue as to how many I've used and how many I've got left and what is that value. So I think you know, one of the keys to unlocking vehicle to grid and vehicle to whatever it might be, V2X, will be ownership of that battery. You know, if that battery is leased from a car manufacturer, or if the whole car is leased from an energy company, for example, then these types of commercial models seem to make sense, because that takes away the worry of the residual life I've got in my battery. I think that's a big issue that we still need to address, and it will be addressed, but we just haven't done it yet.
Great. So I believe that's going to be the end of today's webinar. We've already hit 2:30. We can talk more on hours and hours on related to email. It's a fascinating topic, but unfortunately we run out of time today. So thank you everyone who submitted the questions in today. And the ones unfortunately we couldn't answer, I apologize, we weren't able to get around to them. So thank you everyone, Arnold, Enrique, Tim, Ahmed, everyone from our side as well. Ahmed, do you want to have any conclusions before we shut off the webinar?
No, just thanks for all the speakers and for all the attendees. If you joined late, the recording will be available on the CBC website and the Emirates Green Building Council website. Also, we'll be shared with you by email. So thank you for joining and have a great evening.
Bye-bye, everyone. Have a good day.
Bye-bye. Take care.
Bye.
Bye-bye.
See you.
Thank you.
Thank you a
Bye-bye.
lot.